Bayes' rule. Bayes' rule says that the conditional probability of big Y given big X is the conditional probability of big X given big Y times the relative marginal probabilities of big Y and big X. The probability of big Y equals Y given big X equals the probability of big X equals X given big Y equals Y multiplied by the probability of big Y equals Y over the probability of big X equals X. Bayes' rule 2.22, equation 2.22, obtains from the definition of the conditional distribution in equation 2.17, which implies that the probability of big X given X and big Y equals Y equals the probability of big Y equals Y given big X equals X multiplied by the probability of big X equals X, and that probability of big X equals X and big Y equals Y equals the probability of big X equals X given big Y equals Y multiplied by the probability of big Y equals Y. Equating the second parts of these two equalities and rearranging gives Bayes' rule. Bayes' rule can be used to deduce conditional probabilities from the reverse conditional probability with the help of marginal probabilities. For example, suppose you told your friend that you were dropped by the network 3 times last night while working on your term paper, and your friend knows that half the time you work in the library and half the time you work in your room. Then your friend could deduce from table 2.3 that the probability you worked in your room last night given 3 network failures is 83%. See exercise 2.28. The conditional mean is the minimum mean squared error prediction. The conditional mean plays a central role in prediction. In fact, it is, in a precise sense, the optimal prediction of big Y given big X equals X. A common formulation of the statistical prediction problem is to posit that the cost of making a prediction error increases with the square of that error. The motivation for this squared error prediction loss is that small errors in prediction might not matter much, but large errors can be very costly in real-world applications. Stated mathematically, the prediction problem thus is: what is the function g of big X that minimizes the mean squared prediction error? Big E, open curly bracket, open bracket, big Y minus g of big X, close bracket, squared, close curly bracket. The answer is the conditional mean, big E of big Y given big X. Of all possible ways to use the information big X, the conditional mean minimizes the mean squared prediction error. This result is proven in Appendix 2.2.